You might be thinking that missing view problems are all about matching up the two views you have to draw the missing third view. And that is one way to solve this type of problem, but it's not the only way. I'm going to show you how sometimes using the two views you have to draw a 3D perspective of the drawing might be a little bit easier, because then you can use that 3D drawing to draw the missing third view. I'm going to be doing my 3D drawing in Inventor, but you could just as easily do this with a hand sketch, even if you don't have any experience doing isometric sketching. Just start off with a block, just a plain rectangular block, and do your best to kind of modify it with each feature that you see. Start off with this example problem that has all vertical and horizontal features. So I'll start on the right side view on the bottom, and you can see that there's a rectangular hole that extrudes all the way through from right to left. On the front side view, this is that big long rectangle down at the bottom. On a 3D image, you would draw this by taking the big long front bottom rectangular side and pushing it inwards a little bit to create kind of a cutout or an overhang or a cliff. So right above it, you can see that there's another rectangular cutout on the top half as well. Moving over to the front of the drawing, I can see on the top left, there's a box that's cut out between the two squares that remain. So on my 3D drawing, I can draw that rectangle that gets removed and extrude it into the shape to cut away that top material. Front side view also has this round hole, which on the right side view is shown as hidden lines at the same elevation that extend all the way across the right side view. So on my 3D model, I can draw a circular hole and extrude that back in to cut away all that material. And of course, the big feature on the front view, why didn't I do this one first, is that staircase cutout that cut away is like a third of the entire part. So on my 3D model, I can draw this staircase sort of shape, extrude it through as a hole, cut away a big giant chunk of material, and what I'm left with is a 3D representation of this object drawn from just two of the orthographic views, just the front and right side. So now, instead of trying to draw the top view by referencing the front and right sides, I can try and draw this missing top view by referencing my 3D model. It took extra work to create this model, but then it makes making your missing view drawing a lot easier. On a top view, you're going to want to start at the top and work your way down, because that ensures that your visible lines will be visible, and then the things that are underneath other things you can draw as hidden. Tippity top first are these two rectangles. Next layer down will be that T shape. Another step down from there will be another visible rectangle. And then further over to the right-hand side, one more rectangle. Those are all of the visible surfaces looking from the top down at this 3D shape. You can add hidden lines then for the circular hole, which is, again, underneath. It'll be hidden from the top. And then we can also see that bottom rectangular cutout, that sort of cliff overhang, that would also be shown as a hidden line in a couple of these places as well. So there is a lot going on this top view drawing, and it would have been really difficult to try to draw this whole thing just using the front and right side views. So some drawings, it might make sense to just go from front and right to top directly, but actually these views where you only have vertical and horizontal pieces can sometimes be kind of ambiguous and can often be the hardest type of problems, even though they seem like they should be the easiest. We've got 3 example problems total in this video, so moving on to number 2. And what you'll immediately notice about this drawing is that there are now inclined surfaces. So inclined surfaces are actually extremely useful and really kind of easy when it comes to drawing these missing views. I do have another video about missing views where you just use the 2 views given to draw the third view directly, and it has a great explanation about how to use inclined surfaces to do that as easily as possible. So you may want to open that up in a new tab so you can watch it after you watch this video. But if we want to get more practice about using 2 views to draw a 3D model and using the model to draw the third view, let's start this one off by drawing the holes. Those are going to be the easiest parts to do first. There's a whole lot going on the front view, but maybe if I skip to the top view, you can see that there's a triangular cutout on the bottom right side. So if I draw a triangle on my model and extrude that downwards as a hole, I can cut off that whole corner of material. Next, if I look at the front view, there's a rectangle in the middle that's cut out and two triangles, one right above it and one right below it. I'll extrude that through the part and cut away that whole middle section of material and just leave the top and bottom remaining. And looking back at the given front and top views, this actually accounts for almost everything already. The one thing that's missing is that diagonal dashed line on the top view, which on the front view is this sort of light gray shaded face. So there's sort of a triangle cut out, but it's only cut out of the middle, not the top or the bottom. So I draw a triangle on top of that middle face and extrude it upwards to cut away this other triangle of material. And that's it. That's the 3D model for this part drawn based on just the two given sides. To draw the right side view from this 3D model, we just start at the right side to draw everything that's visible, just working our way from right to left. So you can start off with these really small rectangles that are at the very top and very bottom. Now we've got inclined surfaces, which are pretty tricky to draw, but instead of trying to draw the diagonal lines, just find the endpoints for each of them, which you can match up based on the top and the front view. The top view across the miter line and the front view just traced over. And once you identify the location of that point, then you can just connect the dots to draw that diagonal line. The very center of the shape, even though we know that it's kind of triangular at an angle, when you look at it directly from the right-hand side, it's just going to look like a rectangle, just an empty rectangle there in the middle. And last things will be some dashed hidden lines to represent the holes. You won't have to actually draw very much because most of the top and bottom of the hole actually lines up with existing solid lines, and visible lines have priority. So whenever a visible and a hidden line should be drawn at the same place, you just draw the visible line, not the hidden line. So one problem to go, but if this is starting to make a little bit of sense to you as to why it might be worth the investment to draw a 3D representation before drawing your third view, go ahead and hit the thumbs up to let me know that this is something that's kind of resonating with you. And if there's something else in your class that you've been finding kind of challenging that you'd like me to make a video about, leave a comment down below to let me know. I'm always looking for new video ideas as to what would help you best. All right, drawing number 3. Anytime you have circles or cylinders or holes, it seems like it's going to be kind of tough. And I'm not saying it won't be, but this drawing actually has fewer features than the other ones did. But with my 3D model, instead of starting off with a rectangular block, I'm going to start off with a cylinder because you can see from the front view, it has a circular cross section, and a cylinder looks like a circle from one side and a rectangle from the other side. Maybe the easiest thing looking at this shape is in the very center of the cylinder, there's a small hole. From the top view, this small narrow cylinder looks like it only goes part of the way through, but of course, that's because it reaches another wider diameter hole. So I'm going to go ahead and just extrude it all the way through the whole length. But then next, I'm going to rotate the cylinder around to the back side and draw that larger diameter hole that only goes part way through and sort of meets the smaller hole in the middle. And now we've essentially made like a bucket with a hole in the bottom. And there's only actually one feature left, which is that circular cutout over on the right-hand side. On the front view, this little plus out in sort of the middle of nowhere off on the side of the drawing, that represents the center of the circular cutout over on that side. Right? That little plus has to be there because if you wanted to dimension this drawing, to actually put numbers to it, you would need a point to measure to, and that's always the center of the circle, is where you reference all the dimensions. I draw a circular shape, extrude it part of the way inward, and I can use the top view, that sort of cutout, to see how far in this cut goes. And that was it. It was just one cylinder with these 3 round cutouts. What would this shape look like from the right? So if we want to draw the right side view, we're going to start at the right and work our way to the left so that we draw visible lines first, and then hidden lines will only be whatever is still hidden but not what's behind the visible lines. And the first thing that I'm going to draw is this sort of C shape. And the top is kind of hidden, but you can clearly see the bottom section where when you look at it from the right-hand side, of course you see that vertical sliver, but you see a very small horizontal sliver as well at the top and bottom where you're seeing sort of the inside of this solid piece. And then the center of this C section will be a small vertical rectangle which is looking all the way through the part to the solid inside section of the back of that inner cutout. Of course, I skipped over most of the visible side. Of course, the big round cylinder, you can see, again, another C shape all wrapped around the edge, right? Vertical on the right side and then horizontal along the top and bottom. That's the main outer part of the cylinder that you can see. There are, of course, some hidden lines. Using the larger circular cutout, you'll see hidden lines along the top and bottom of that circle, as well as at the depth, the furthest in that it's pushed. And then for the very smallest hole, you'll also see hidden dashed lines to represent the top and bottom of that hole. No vertical hidden line for this one though, because it coincides with a visible line that's already drawn, and visible lines have priority over hidden lines. 3 third view sketching problems completed, all by adding an extra step of drawing a 3D model before drawing the missing view. But if you've gotten to this point and realized that your 3D drawing ability is nowhere as good as it needs to be and you're not going to be able to use this method, then watch one of these other 2 videos. It's up on the screen now. I do have some other ways where you can make your missing third view drawing without having to do a 3D drawing first. You just go straight from the 2 views you're given to the third view that you're not.